Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, identifying scalene, isosceles, and equilateral triangles given coordinates of their vertices. So this one is very much a kind of rote brute force problem for a little bit. So most of the interpretation is actually at the end. So there's going to be a lot of distance formula here. So just to help see what's going on, if you imagine a generic triangle here, I'll do these first ones, J, K, and L as my points. So I need to use those points to find my three sides here. Okay, so I have this one, and this one. Okay, so I'm going to do three distance formulas for each one, and I'm going to need to find the distances of each of those sides. Now, some of them are going to be a little bit simpler than others. For example, these both have -5 as my coordinates, so that'll help speed things up. But I'm going to run you through all the way how to do one, and then we're going to skip forward and just get the distances for the last two, and then we're going to do all the interpretation together, but just so you don't sit here and watch me work through a bunch of distance formulas. All right, so I need JK as my first one. So the distance formula is going to be the square root of the differences in the y's. X's, doesn't matter which one you do first, squared, and y2 minus y1 squared. Because remember, this is really just a variation, or an application, I should say, of the Pythagorean theorem. So don't forget your squares in there. So I need the difference in my x's. So if I'm looking at j and k here, I'm going from 2 to 1, so that is 1 squared. Here, I'm going from -5 minus 0, which is -5 squared. So 1 squared is 1, -5 squared is 25. So I should end up with the square root of 26. And actually, for this application, it's probably easier if you don't try and get a decimal here. Just leave it as the square root of 26. And it's going to save you a little bit of time and actually be easier to interpret. So then I need to do this again for KL and again for JL. So I'm going to go ahead and do those quickly, and then we'll skip forward and get the distances for B and C. So effectively there are 9 distance formulas in this problem. So here I want K and L. So it's -3 minus 2, which is -5, and -5 minus -5 is 0 squared. So I get the square root of 25 plus 0, which is just 25. So this one comes out nicely. If you want to leave it at the square root of 25, or if you write it as 5, it doesn't really matter. Okay, and I also need JL. So here, don't forget my square root. -3 minus 1 is -4 squared. -5 minus 0 is -5 squared. So I get the square root. I'm sorry, I'm running off a little bit. 16 plus 25. So that comes out to 41. So if I look at these, we're going to go ahead and interpret this one quickly. Then we'll do B and C. So remember, scalene is all 3 sides are different lengths. Isosceles is 2 angles, or 2 sides are the same length, but one's different. And equilateral, they're all 3 the same. So look in this, I have radical 25, radical 26, and radical 41. Those are all different, so that would be a scalene triangle. Okay, so I'm going to pause here for a second, work out my other distance formulas, and then come back and we'll interpret them. Okay, so just work through those. So here we have DE, EF, and DF. So here I have one side that's 6 and 2 that are radical 58. So we have an isosceles triangle because we have 2 that are the same and 1 that's different. And then over here we had 2 radical 41s and a 10. So once again, this is isosceles because we have 2 that match and 1 that's different. So the only way to get an equilateral one is to have all 3 be the same, which did not happen here. But if you do that, that's equilateral.